Yeah, my name is Vladimir. I'm the head of crowdsourcing tools development group at Toloka. Toloka is a crowdsourcing platform, and recently we developed Toloka Kit and CrowdKit libraries for interacting with our platform. During the development of this projects, we encountered several problems with IDE support, and today I will talk a bit about what problems we encountered and how we dealt with them. So let's start with IDE hinting. Today I'll be show everything on an example of my PyCharm, but technically it should be quite the same in any other IDE. So let's say we want to implement a module that is called Sleepy. Sleepy module would contain a sleep4 function. The difference between the standard library time sleep function and our sleep4 function would be that sleep4 function would accept a time unit. So we would be able to say sleep for half an hour, 1 day, 2 weeks, or something like this. We implemented this module, and we can see that if we use the sleep4 function somewhere in our code, IDE shows us the signature. If it starts printing the argument name, it auto-completes it. And if for some reason we passed an argument that should not be there, that is not expected in the signature, IDE would highlight this argument. We would see that we are doing something wrong before running the code. But let's write a simple decorator. Let us write a decorator that is called log function call, and it does what the name says it does. It would write a line of code in the logging stream every time we run a function, and every time the function is complete, we would write another message to our logging info. Technically, one would implement the log function call decorator like this. Now, if we configure our logging and we run our sleep4 function, we can see that everything works. We can see these lines of code in our terminal. But what happens to our IDE hints? So if we start using this function in our code, we can see that we no longer have signature highlighted. We no longer have argument autocomplete. And if we pass an argument that shouldn't be there, it is not highlighted, and IDE does not pick that we are doing something wrong. Everything is gone somewhere. So what are possible reasons for this? Technically, we could think that that's perfectly fine behavior because actually decorators are substituting one function for another one. So we defined a function that is called wrapper, and we substituted our original function with the wrapper function. But signature actually is still there if we import an inspect module, and from the inspect module we use inspect signature function on our function to just view the signature. We can see that the signature is still there. The trick is that functools wraps actually preserves the signature in a specific attribute, and it is there at runtime. But why our IDE could not pick that information up? Well, the reason for this is exactly what I told. The information about the original signature is stored in an attribute and is available at runtime. But IDE does not run our code and does not have an access to runtime objects. IDEs use static code analysis, and there is plenty of reasons to do so, starting with your code possibly having some side effects, like if you run the code without your knowledge, IDE could damage some information on your hard drive or do something like this. The code might raise an exception, or it might not just be a syntactically correct code. So if you're typing the name of your function, you did not yet write the name to the fullest extent, your code at this moment is not a syntactically correct Python code. So IDEs IDEs are using static code analysis, and the static code analysis is actually a much more difficult task. So IDE has to understand something about your code without actually running it. What can we do to help IDE highlight the signatures and give us hints? Well, actually, generally, the good idea is to provide our IDE with as much information as we can in our code. In this particular case, we could do something like this. So our original decorator looked like this, and we can provide additional information in form of typing. So here we are telling our IDE that the log function call is accepting something and returns something of the same type. In our case, if the log function call is accepts a function with some signature, it should return the function with the same signature. And let's see how this works. For some reason, signature, at least in my PyCharm version, is not highlighted, but if we start typing the argument name, we can see that there is a pop-up window above that lists the whole signature. So actually, the information about the signature is in our IDE, but for some reason, it is not used to the fullest extent. I guess that the same thing is with an additional argument, but the main thing here is that IDE has that information, and the fact that it does not highlight something, I guess, is due to some minor bug. So IDE has the information and can technically do this. Some other IDE might do the better job than mine. But that was actually a very simple decorator. And even a simple decorator can confuse the IDE hinting. But in real life, we might want to implement some more difficult decorators that we will not be able to annotate properly to help IDE cope with this. Let's go back to our sleeping module, and let's say that we got a feedback from our users that our function is quite good, but they do not want to import time units enum every time to use it. Our users want to be able to use both time unit enum and the string literal. So what we do, we write another decorator that is called autoenum that would do the following. It will take a function, analyze the signature, pick the arguments that are annotated as enum types, and for those particular arguments, we'll try to cast all the arguments that pass to the enum value. So the code would look something like this. It's quite complicated, so let's go through this. First of all, we take the original signature of our function. Next, we bind our arbitrary arguments, arc and quark, to the original signature in order to understand which values are passed to which argument names. Then we traverse pairs of argument names and values passed to these arguments. And in case in original signature, this argument was annotated as enum, and if for some reason the value passed to this argument is not an enum, we assign a new argument that is argument annotation of original value. What this does is it takes an enum class and creates an enum instance from a string literal name. There is a big chunk of code that preserves the signature. So what it does is, if we want our new function to accept both enums and string literals, we want to update the annotations so that every enum annotation is replaced with a union of enum and some string literals. So what we do is we recreate a signature object in this code, and we assign it to a dunder signature attribute. So this is the protocol to override the signature for introspection. What happens? Now we see that our IDE highlights minute string as an invalid argument, but if we run the code, we can see that both versions of our code, the one with the time unit and the one with the string, are actually working. And if we output the signature that we can introspect, we can see that this signature is actually updated. So as a unit, we should be able to pass both sleepy time unit, which is an enum, or one of the following literal: seconds, minutes, hour, day, or week. But for some reason, IDE does not pick this, and we know why. In this particular case, the code is so complicated that it is intuitively it is quite intuitive that understanding which signature should be deduced from the code without running it is quite equivalent to actually running the code. So this is very, very, very difficult problem, and we cannot think of annotations that would simplify the work for our IDE. What we propose here are stub files. What are stub files? Stub files are special files that were introduced in PEP 484, and they the main purpose of these files is to hold the typing information for modules. So when the typing was first introduced, developers wanted to implement Python 2.3 compatible modules. But if they used annotations in these modules, this would not be a syntactically correct Python 2 code. So they needed an approach to still benefit from type hinting, but not break the compatibility with Python 2. And here, stub files come into play. And what they are actually just Python files with extension PYI that should be called the same way as the original module. And if IDE finds a stub file, it would use the stub file instead of the original file in order to get all the information for the hinting and for typing. So what should we add to stub files? In our experience, we should add all the public members, annotations, doc strings, final function signatures after we resolve all the decorators. Where possible, it is best to preserve constants, and we should add all the imports for the code to be a valid Python file. And what can be omitted? We can omit private members, decorators, and function implementations. So in our case, we can write a stub file that is called init.pyi, and in that file we would put a sleep4 function that has the signature that we want our IDE to pick. We omit the implementation, but we want the signature to be syntactically correct, so we need to import union, literal from the typing module, and we need to add the definition of the time unit. And to define a time unit, we need to inherit from enum, and to inherit from enum, we have to import enum. So our file would look like this. We have the final signature, the desired signature for our sleep4 function, no implementation, and everything that is required for this file to be syntactically correct Python. Now we have PEP 561 that says that any package maintainer that wants to support stub files has to put a marker file named py typed in his package, their package. We do exactly this. We create an empty file that is called py typed. This is an indicator for the static analysis tools for our IDE that it should look for the stub files in the module, in the package. Let's see what happens to our IDE hinting after we added stub file and py.typed empty file. We can see that we can once again see the signature. We have the autocomplete, and if we type an argument that is not there, it is still highlighted. And we can see that if we pass a string instead of the time unit num, it is not highlighted as an error. So I guess we fixed everything and we received everything we expected. But and it works. But there is a problem, and the problem is that now so the reasoning for using all those decorators was to eliminate the boilerplate. So we wanted to simplify our coding process, not to write some code every time, and we put this logic to decorators. But now to support IDE correctly, we need to maintain stub files all by ourselves. And this is a burden and defeats the purpose of using the decorators in the code. So what we propose here is automatic stub generation. Long story short, the IDE is using static code analysis because it is afraid to run our code and does not have an access to runtime objects to introspect them. But if we write our code correctly and we assure that our code does not contain side effects, and we can safely import our code without those side effects, we can help the IDE by importing our modules ourselves, and from the imported modules, introspectively introspect the module and create stub files without decorators, without the KV logic that the IDE would be able to pick. That was a lot of words. Let's write some code just to feel how this approach can be implemented. So if one wanted to implement this approach, one would write the code that would look something like this. Let's go through it. First of all, we have a function that receives a name of a module and a path to a source code. And what it does, it imports the source code by the path as if it was a module named name. So we will see later how this works. Next, we would have to create a special function that generates the stub files. So this function would accept a module object, and this is a simplified version that would only generate the stub files for functions. So what we do here is we take our module, we traverse all the attributes of our module, and then if the value that is stored in the attribute is a function, and this function was defined in the specified module, because some functions might be imported from somewhere else. We only want to create the functions that are defined in our module. So if this is a function defined in our module, we write def keyword, the name of the function, the signature of the function, and an empty body. The function main, the only thing it does is it takes a path to a module and imports it, and then creates the stub file and writes the stub file into the file that is called the same but ends with I. So if we take a sleepy.py module, it will write the stub file to sleepy.pyi. And we run the code for our sleepy module. So we want to import the sleepy module as a sleepy module, and it is located at sleepy/init.py. So we run the code, and what do we get? We get a long line of code, but if we refactor the code, we would see something like this. So we have a sleep for function and a signature that is pretty much similar to what we expected, but not quite. From this simple example, we can already see what difficulties would we encounter on the path of this approach. So this was quite a simple code, and it generated not syntactically correct Python file. First of all, there is a problem with the default value. And second of all, we did not import everything that is required for this file to be a valid Python file. So we did not import union, we did not import literal, and we did not define sleepy time unit. But the idea is quite clear, and technically, with some efforts, this code could be we could write the code that does everything just fine. And what we did is we actually wrote this code. There are several constraints about our code. For some reason, it was easier for us to rely on $all attribute in every module. So our tool requires every module to have a $all attribute. So let's add the $all attribute to all our modules and run our tool. Our tool is called StubMaker. It accepts the name of the module. It accepts the path to the module, to the package, and output directory to generate stub files into. What we get is we get automatically generated stub files that are created by introspecting the runtime objects. If you wonder why time unit now has a docstring, that's because every time you actually inherit from an enum class, your class is automatically added with this docstring. So if you inherit from an enum and you write help on this object, you will see exactly this command, and this is the docstring that our tool picked from the runtime object of the time unit. So all the other modules are quite boring, but what we did is we automatically generated stub files. We no longer have a burden of maintaining stub files ourselves. And the bonus. So everything I was talking about was on an example of IDE support, but actually this holds true for every static code analysis tool. And every static code analysis tool has the same or similar problems. And MyPy is not an exception. So in cases in the beginning where our IDE did not highlight arguments that were not supposed to be passed, MyPy behaves the same way. And fixing the behavior is fixing this behavior can be done with stub files. So if you create the stub files for your project, this might improve your typing analysis with MyPy too. So thank you for your time. What I have here is two QR codes. The one below is the QR code to the GitHub account of our where we open source the tool, and the one above is the QR code for for the Slack community, where you can find me and ask some questions later on if you want to. Thank you.
Thank you, Vladimir. That was a wonderful, wonderful session. I'm sure the audience learned and enjoyed the session as much as I did. Any final thoughts before we part ways for today, Vladimir, on Open Source India and your experience at the same?
I was expecting some questions if
I don't know. I mean, we don't have any questions as of now.
Oh, okay. So I don't know. I like talking. I like this session. Everything is great. So thank you for having me.
Thank you, Vladimir, and we hope to see you here again soon.